Okay, so we're going to take another look at this identity that we verified in the last video and try it another way. We always start by picking the more complicated side to start with and making it equal the less complicated side. But in this case, both of these sides are pretty equally nasty looking. So in the last video, we started with this fraction and we showed that it equaled tangent of theta plus secant of theta. This time, let's try it the other way. Let's start with tangent of theta plus secant of theta as our given information. And then we'll show that it is equal to this 1 plus cosecant of theta all divided by cotangent of theta. So the first thing that we're going to need is a quotient identity. So if we recall our trig hexagon for the fundamental trig identities, tangent is over here on the left, and we've got sine and cosine beside it, and then we use our reciprocal identities. So cosine's reciprocal is secant, sine's reciprocal is cosecant, tangent's reciprocal is cotangent, and in the center we'll put the 1. So this hexagon with the trig identities, if we want to find quotient relationships, we look for consecutive vertices either clockwise or counterclockwise around the circle. So, for example, we could represent tangent, if we wanted to go counterclockwise around the circle. We could show that tangent is the ratio of the secant divided by the cosecant, right? But since I'm trying to end up over here with a denominator of cotangent, having a denominator of cosecant might not be super helpful. So instead, let's try going clockwise around the hexagon. So tangent is the quotient of the sine divided by the cosine. And that also would not be super helpful in having a cosine denominator when I'm trying to get a cotangent denominator. So it looks like a quotient identity won't be super helpful. So instead, why don't we look at the relationship across these diagonals where we see that tangent is the reciprocal of cotangent. So that would not be a quotient identity, it would be a reciprocal identity that we could rewrite tangent of theta as 1 over the cotangent of theta. So that reciprocal identity would get us a cotangent in the denominator, which is what we're looking for in this case. So that's what we'll do for our step number 2. We're going to change tangent of theta into 1 over cotangent of theta, and the reason for that is going to be applying a reciprocal identity. So next, in step number 3, we're going to take a look at this secant here, and we want to represent secant with a denominator of cotangent. And looking back at our trig hexagon here, let's see if we can put it back together. That's a 1 in the center. There we go. So secant is down here. And if I were to try another reciprocal identity on secant, secant's reciprocal is cosine. And I don't want to have a denominator of cosine. I want to have a denominator of cotangent. So we're not going to use a reciprocal identity a second time. But if I look at my quotient identities again, right, secant going clockwise around the hexagon is the ratio of tangent over sine, which I don't want a denominator of sine either. But if I go counterclockwise around the hexagon, secant is also the quotient of the cosecant divided by the cotangent. And that would get me a denominator that I want. So I'm going to use this quotient identity, secant, is equal to the cosecant divided by the cotangent. I'm going to apply that identity to step 3. So I start with my 1 over cotangent of theta, and now in place of secant, I apply this quotient identity that I discovered on the hexagon. So cosecant of theta divided by cotangent of theta, and that was applying a quotient identity. Okay, and that was step number 3. So now in step number 4, I look at my two fractions and they have a common denominator. So I can go ahead and add the numerators, 1 plus cosecant of theta, and put that numerator now over the common denominator, cotangent of theta. And that reason that goes with that statement is how you add fractions. Okay, and now we can see that we have arrived at our destination because we have now shown what we set out to show, which was that the tangent of theta plus the secant of theta, that was our given information in step 1. We've now shown that it matches the other side, 1 plus cosecant of theta over cotangent of theta, just like we wanted. And so this trig identity is verified.